Hello everyone. Today I am going to discuss about flip-flops. So what is a flip-flop? The concept of flip-flop comes from the gated latch. The working principle of flip-flop is similar to the gated latch, but the only difference between a gated latch and a flip-flop is that flip-flop uses clock signal instead of using enable input. So, the function of clock pulses are same as that of the enable input. So, this is the block diagram of an SR flip-flop. You can see that S is one input, R is one input, Q is the output, Q bar is the complemented output. Now, in case of gated SR latch, we are using enable input here, and in case of flip-flop, we are using clock signal here. The clock signal is denoted by CLK. So, when the clock pulses are high, like if this is the clock pulse, so when it is high, that time the flip-flop changes its state according to the inputs. That means we will get output of the flip-flop according to the inputs we provide. Similarly, when the clock is low, the inputs remain inactive and no change in the output occurs. So we can say that the flip-flop is a synchronous device. Synchronous means the changes in the flip-flop occurs at a specified point on a triggering input. The triggering input is called as the clock input. Okay, now coming to the triggering of flip-flops. So, a flip-flop is triggered when the clock pulse is high. So, if this is a clock pulse, so the flip-flops are triggered. Triggered means the outputs change according to its input. It can occur when the clock pulse is high, so it can occur at any interval of time, or it can occur at any specified instant of the time duration for which the clock remains high. So it can occur at the positive going clock pulse. When the clock, it is 0, it is 1. Now when the clock pulse starts going from 0 to 1, at that time the triggering of flip-flop can occur. The triggering of flip-flop can occur for the whole time duration for which the clock pulse remains high. Or the triggering of flip-flop can occur when the clock pulse is going down from 1 to 0. That is, the triggering of flip-flop can occur at that time. Okay. So, based on the specified interval or the specified point in the clock during which the triggering of flip-flops take place, it can be classified into two different types. One is level triggering, another one is edge triggering. So in today's video lecture, I will be discussing about the level triggering of flip-flop. So what is level triggering? You can see this clock pulse. So in this clock pulse, suppose it is T1, it is T2. Now at time instant T1, the clock pulse is going from 0 to 1. Then from time T1 to T2, the clock pulse remains high or it remains at logic 1. Again at time T2, the clock pulse is going down from logic high to logic low, or from logic 1 to logic 0. So in case of level triggering, we will get outputs of the flip-flops according to its input for the whole time duration when the clock pulse remains high. That is, from T1 to T2, we will get output of the flip-flop according to its input for the whole time duration when the clock pulse remains high. Okay. So this is known as the level triggering of flip-flop. Now, this level triggering can be classified into two another types. One is positive level triggering, another one is negative level triggering. So what is positive level triggering? In case of positive level triggering, we will get output according to its input when the clock pulse is at positive level or at high level. That is, in this clock pulse, for the time duration T1 to T2, it remains at its logic high. And for this period of time for which the clock pulse remains at its positive level or high level, we will get outputs according to its input. This is the positive level triggering of flip-flops. Now coming to the negative level triggering. In case of negative level triggering, what will happen? If this is a clock pulse, this is logic 1, this is logic 0. This is time T1, time T2. Now, in this clock pulse, at time T1, this clock pulse is going from logic 1 to logic 0. For time duration T1 to T2, it remains at logic 0. And at time T2, the clock pulse again goes from logic low to logic high, that is from 0 to 1. Now, for the negative level triggering of flip-flops, the output will change according to its input when the clock pulse is at logic low. Logic low means the clock pulse is at 0. That is, from time duration T1 to T2, the clock pulse is at 0 level or low level. So, for negative level triggering of flip-flop, the outputs will change according to its input for this time duration T1 to T2, for which the clock pulse remains at its logic low state. Now, how to draw the block diagram for negative level triggering? In case of negative level triggering, we just add, okay, let's draw another diagram, then it will be clear to you. Suppose this is the block diagram of SI flip-flop, S input, R input. Okay. This is the output Q, output QR. Now, in case of negative level triggering of this flip-flop, we will just put a NOT gate in the way of the clock pulse. So, if this is the clock pulse, now the clock pulse is going to the input side of NOT gate and the output of NOT gate is going to the flip-flop. Now, we denote this thing by just simply putting a bubble, like S input, R input, and in the clock input we just put a bubble here. So this bubble denotes that this flip-flop is negative level triggered. Okay. And for positive level triggered, here there is no bubble here. That means this flip-flop is positive level triggered. Now, there are some drawbacks of this level triggering. To understand the drawbacks of the level triggering, let's come to the waveforms. So this is the waveform of an SR flip-flop. It is the waveform of S input, variation of S input according to variation of time. The time is plotted against the x-axis. The S input is plotted against the y-axis. Similarly, this is the waveform of R input. Here R is plotted against the y-axis, time t is plotted against the x-axis. This is the waveform of enable input, or in case of flip-flop we can say this is clock input. So the clock input is plotted against this y-axis, time is plotted against this x-axis, and this is the output waveform. Now let's discuss about this waveforms. So from the waveform it is clear that if it is time t1, t2, t3, t4, t5, t6, t7. Okay, now starting from time 0 to time t1, the S input remains at logic high 1. For that time the enable input is low. Enable input or the clock input. It is better to say clock pulse or clock input in case of flip-flop. It is low. Now we are assuming that it is a positive level triggered flip-flop. So when the clock pulse is at logic low, the output of the flip-flop will not change, and we are assuming that initially its output is 0. So the clock pulse is at logic low, then and initially its output is at logic low, so output will not change for this time duration starting from 0 to t1. Output is 0 here. Now at time t1 the clock pulse is high, and from time t1 to time t6 it remains high. From time t1 to t6 the clock pulse remains high. Now as it is a positive level triggered flip-flop, we will get its output values according to its input values for the time duration t1 to t6. Okay, now coming to the output waveform. From time t1 the output will change according to its input value. So we have to find out at time t1 what are the input values. So at time t1 the value of S is 0. From time t1 to t2 the value of S is 0. Now coming to R, from time t1 to t2 the value of R is 1. So what will happen when the R is 1 and S is 0? The flip-flop will be reset. Reset means its output will be 0. So from t1 to t2 its output is 0 here. Now coming to the next interval of time. Now from t2 to t3 S becomes high, logic 1, and for time t2 to t3 R is 0 or at logic 0. So when S is 1 and R is 0, the flip-flop will be set. That means its output will be 1. So for time t2 to t3 its output is 1. Next coming to next interval, that is at T3, the age becomes 0. From T3 to T5, age remains at 0. And from T3 to T4, R is 1. So R is 1, age is 0, that means flip-flop will be reset. So its output value is 0 from T3 to T4. Next, at T4 from T4 to T5, age is 0, and from T4 to T5, R is also 0. If both are 0, so there will be no change in its output. Output continues to remain in its previous state. That is, prior to time T4, output was 0. So from T4 to T5, output will remain at 0. There will be no change in the output because both the input S and R both are 0. Now at time T5 becomes high again. From T5 to T6, S is high, and from T5 to T6, R is low. So the output will be high. At time T5, output becomes high. Up to time T6, the output remains high, and at time T6, the clock pulse becomes low. So if the clock pulse becomes slow, then after time T6, the output will continue to remain in its previous state. That is, the output will continue to remain at logic 1 after time T6. Now we can see that from time T1 to T6, the clock pulse remains high, and in this duration of time from time T1 to T6, the output changes a number of times. From time T1 to T2, the output is low. Again from time T2 to T3, output becomes high. Again time T3 to T5, output is low. Again at time T5, output becomes high. So there are many changes in the output. Output changes a number of times for this interval of time when the clock pulse is high. So this is the main drawback of the level triggering of flip-flop. That is, when the clock pulse remains high, for the whole time duration, the output changes a number of times. That is the main drawback. And to overcome this drawback, age triggering of flip-flop is used. So this age triggering of flip-flop will be discussed in my next video lecture. Thank you.